Okay, folks, thank you for joining. So, yesterday we gave an overview of what are the various things going on in MySQL and HeatWave. And what I was going to now talk about are some of the things we are doing in MySQL. And the thing to clarify, I guess one of the most important things is that, as Vem said, and you folks know, that not only large organizations worldwide run on MySQL, but the most innovative organizations worldwide, they run on MySQL. Now, if the organization is innovative, they want to make sure that the underlying technology is also innovative. So that's why it's very important for us to keep innovating. And a lot of the things which you're going to see, we may talk in the context of the cloud or such, but keep in mind our goal is to provide a very high quality product, both for on-premise as well as for the cloud. So one of the things which may or may not be clear is that we are the only vendor which offers a fully managed MySQL cloud service, but also can make changes or enhancements to the product, right? So we are the only ones who develop the MySQL product and we ship it. Now, one of the very interesting synergies is that when we are taking our product, deploying it at scale for various kinds of use cases, very large use cases, we find issues, right? These issues could be bugs, issues could be enhancements. Now, the bugs not a problem, right? I mean, those bugs, hopefully they're generic and it's easy to fix them. But some of the times, these enhancements which we find for the cloud, not all of them are applicable for on-premise, not all of them can be done for on-premise, but when possible, we try to take these enhancements and offer them in the on-premise product. So the thing which you have to understand is that we have been running HeatWave MySQL Managed Service in the cloud for 4 years. We have very, very large customers, right? Including customers like NVIDIA, including customers like 8x8, who have very mission-critical workloads running in the cloud with the HeatWave Managed Service. And over the years, they have found many enhancements, they have found issues, and we have been rolling them back into the product. So one big area where we have made a bunch of enhancements, improvements, is in the area of availability, which is probably one of the most important things for customers, whether it's on-premise or the cloud. And Louis has a talk soon after my session where he's going to go into details about what are we doing in terms of enhancements for HA4 on-premise. And many of those enhancements, the ideas of the implementation has come for the cloud, right? So I would highly encourage you guys to stay back for the next session because that's probably going to be a very, very useful talk. But the second thing is that even not enhancements in the existing features, but new capabilities, right? So to give an example, we had this notion of this auto thread pool. This was something which we did in the cloud. And the reason we did that in the cloud is because in the cloud we have machines which have a large number of cores, and we were looking at the utilization of the cores, and we said, you know what, we should be able to do a better job in terms of handling more connections because the cores are underutilized. That's where the idea of this auto thread pool came about from. We have always had thread pool in the MySQL Enterprise Edition, but the idea of the auto thread pool really came from there. So that's something which we incorporated in the product. Another thing is the support for JavaScript. Like as we talked about, JavaScript is one of the most popular languages for developers. And it's something which has a very high performant Graal VM engine, which was built in the labs. We have incorporated that. And we said, you know what, sure, the cloud provides a very good platform for developing new applications. But many of the on-premise customers, they would take the data, they would fetch the data out of the MySQL database to the client for this development. So if you can offer it natively inside MySQL, that will be very useful. So that's something we have done, right? So we are continuing to make improvements. Hypergraph is another example. Hypergraph, next month we are going to enable it by default in the cloud, and it's already enabled by default for HeatWave for the analytics side of things. Provided us very good feedback. We have fixed a lot of issues. The optimizer team has fixed a whole bunch of issues, and now we are at the point where the complex queries are just fine, they accelerate. For the simple queries, we were still seeing some regressions, which the team is working on. That's another example of a very important, it's like, several dozen person years of work which has gone into the Hypergraph optimizer, and that's also something which is being rolled into the on-premise edition. So the point to note is that for many, many features which are in the cloud, we roll those enhancements back to the on-premise. In some cases, it's for existing workloads, like HA is one good example of the Hypergraph, but in some cases, it enables new workloads or new applications, like is the case with JavaScript. So just to like recap, and I'm sure you've seen this slide, right? Like, so HeatWave is a data processing engine. It does multiple things: transaction processing, analytics, machine learning, generative AI, processes data both from MySQL as well as from the object store. But the thing to note is that since we are building this generic engine, right, which scales out, its in-memory engine, it does a whole bunch of things. We have a lot more opportunity now to even enhance the generic MySQL engine so that it can cater to the needs of HeatWave. Many of the enhancements which have happened in the optimizer in terms of, let's say, like a nesting of complex queries, the enhancements which we are doing in the views to support JSON duality and such, that is coming because of the requirements of HeatWave. And HeatWave does not just transaction processing, but other kinds of processing as well. So what that means is that over time, we are improving the generic standalone MySQL so that it is efficient for some other workloads as well. Right? Another example in the context of generative AI is the vector data type. Right? Now, the vector processing, generative AI, that's super optimized for the cloud. Right? So we run in database LLMs and such. But many of the enhancements we made, including the vector data type, they're available on-premise. So we are already doing so, and I expect it to be the case more, that the needs of HeatWave, both in terms of scale and the kind of computation we need to do in HeatWave, will drive more enhancements in MySQL. And the second aspect to notice that if you're developing applications, and this is one of the things people really like about HeatWave, is that all tools and applications which work with MySQL will also work with HeatWave when it's querying data in the object store. And that's a very, very compelling message, right? Typically, you have these MySQL applications running on data which is inside the MySQL database. But now if you have some data, like a CSV file in the object store, you can actually have a MySQL application talk to a CSV file in the object store. And this is something which will enable new class of applications, right? So what we have always believed, and what we continue to work on, is two things. Make MySQL the best choice or the best platform for customers to develop new applications. That's one. And the second thing is make MySQL the best platform for customers to deploy those applications. And that's something which you're going to continue to work on. And when it comes to deployment, again, we want to offer full flexibility. So one of the things which I think which has been talked about, but I just want to emphasize, Oracle or the HeatWave service is the only managed MySQL service which runs the enterprise edition of MySQL. Right? Everyone else, whether it's AWS, Azure, GCP, everyone takes the open source version of MySQL and they offer it as a managed service. Now, over time, we are making a lot of good enhancements in the enterprise edition, but there can also be some compatibility issues which people are worried about. We are the only ones who take the enterprise edition of MySQL and offer that as a managed service. So what that means is that all tools and applications which are working in the open source version will work in enterprise, but they will also very, very seamlessly work and migrate to the cloud. So there are 4 topics I was going to briefly cover. Performance, because that continues to be a very important thing for all databases, right? And the thing to note about performance, particularly in the context of on-premise, is that if we make the performance of a software on-premise faster, what that means is that you can use less hardware, you can pay less for hardware if your software has become faster. So for instance, if you're improving the performance of query processing by 2x, you could potentially pay half for the hardware and get the same performance, right? So improvement in performance in software or in MySQL translates to reduced expenditure for the customers for hardware, right? So that's something which is an important area for us and we'll continue to work on. Hypergraph Optimizer, right? So you've probably heard about it. We are very, very excited about it. It's something which has been worked for many, many years. We have spent several dozen person years on it, probably over 100 person years easily, both in the core development, optimizing it and enhancing it for more and more use cases, right? In a nutshell, in case you didn't get a chance to attend Norval's talk yesterday, right? In a nutshell, what the Hypergraph Optimizer does is that for complex queries, particularly queries involving joins, it explores a larger search space, right? So any optimizer compiler explores a search space, which are the possible execution plans, and then figures out which is the best execution plan to run that query. So if you don't, so if you can expand the set of search space or the possible execution plans, the optimizer is going to have a better chance of coming up with a better execution plan. That's what hypergraph is. So for join queries, the complex queries, we explore a larger search space. Plus, we are collecting new kinds of statistics, for instance, sketch-based statistics. And we feed these more accurate statistics, more rich statistics to the optimizer to determine which is the right execution plan. So hypergraph, just to be very clear, is not going to improve the performance of your simple queries. In fact, it may not even improve the performance of other complex queries which don't involve joins. But if you look at any workload, any database application workload, the total cost is dominated by the most complex queries. And the most complex queries are the ones which typically involve the most complex joins. That's why we're attending to the queries which really matter. And our belief is that if we can improve that, it'll aggregate, improve the performance of your overall application. Right? So that's why the focus of this is not to improve the performance of all queries. No. It's only for the most complex queries and the queries with joins. And the more complex the joins are, hopefully you will see a better improvement. So in the past, there has been a perception, right or wrong, that Postgres is better at complex queries. Now, what this graph is showing is that with hypergraph, what is the performance of the optimizer compared to Postgres, right? So the workload we are using over here are two, TPCH, TPCDS. One of them is distance support, other is like, a warehouse. Now the mileage will vary. These are just two benchmarks, right? The mileage will vary. But as you can see in both the cases, the hypergraph optimizer of MySQL is significantly faster than Postgres. Now it's not to say that you can't find some queries where Postgres may be faster, maybe, right? But the most complex queries, and this is an aggregate of like, TPCDS has 99 queries, TPCH has like about 22 queries, right? These are a lot of queries, and these are representative of what typically customers run. And this is without HeatWave, by the way, obviously. So this is a standalone MySQL instance without HeatWave, right? It is like many, many times faster than Postgres. So what we believe is, with this enhancements now, if you have queries which have mixed workload, which have complex queries, which are the ones which typically dominate the performance of the runtime of your application, those will become faster. So this is something which is going to be enabled by default in the cloud next month. It's already available in the Enterprise Edition, and we are working on it just to kind of make sure that it's even more stable after we get feedback from the cloud, from HeatWave, and hopefully in the future we will enable it by default in the Enterprise Edition, but it's something you can do even now, right? So the thing is, we just think of it from a blast radius perspective, right? This is a new optimizer. It does a lot of good things. We just want to make sure it doesn't regress too many applications, and that's why we're just going slow in terms of the way we roll it out. But the improvement is significant. The second thing is the load, right? So if you look at any database, there are two things. You want to get the data in, and then you want to query it. So the query part we talked about. Now, one of the things which has been a little bit of a suboptimal thing about MySQL is InnoDB handling large data sets, right? So if you look at any customer, there's a very high chance that most of the customers are going to be in single-digit terabytes, if that, right? I mean, we are hard-pressed to find customers who have a single instance, say, over 10 terabytes. So what happens is that even though you may have a theoretical limit of supporting 128 terabytes or such, most customers at deployment use a smaller instance, a couple of terabytes, maybe 10 terabytes, and then they do sharding at an application level, which is okay, but again, that's not like desirable. So what we've been working on, and again, it's an ongoing project, we have made a lot of progress that we are able to now load data, bulk load, and initial creation time really fast. And it's something which we rolled out like, last year. But now the enhancement we have done is for the most part, right, since it's an IoT, people create secondary indexes. And now even with secondary indexes, you can see there is a significant speed up over regular load, right? So we are already seeing customers when they were migrating to MySQL cloud service or to HeatWave, that loading time was very large. And with this feature, it has provided significant acceleration. And we are continuing to handle more and more data types. And I'm hoping that in the next year or so, this will be something which itself is a major differentiator, right? And only available with HeatWave. But this is the way, like in fact, like when we get feedback from folks like yourself, this is what tells us what to prioritize. And this really came as a result of feedback from our customers saying, look, MySQL is great, simple to use, easy to use, but you know what? When the time comes for handling mid-size data sizes, they think about other choices, or it's too much of an overhead for them to shard at the application layer. And that's why we have undertaken this project. The next thing is, in the past, whenever we would do writes, internally we were doing the write twice. And now the MySQL team is co-located with the Linux team and working collaboratively. Now the Linux team has provided an operator at the Linux level, which basically does the atomic write. So this is something which does not need to be done in MySQL. So for write-intensive workloads, it will basically improve your performance almost 2x. And then finally, we continue to make incremental improvements and obviously attend to regressions, which we noticed over the years. So this is just a comparison of 2 releases. 8.0.35, we had a bunch of enhancements, but even now, we continue to make enhancements. And the key thing to note is that with any performance improvement, it is, again, as I said, reducing the amount of hardware which customers need to provision for an on-premise instance. And for the cloud, it's all about price performance. So this is something which makes the value proposition of the managed cloud service better. Now about high availability, right? So if you ask the number one reason why customers like or consider a managed service for a database, it's availability, right? Because the other choice is you can self-manage your database, and that gives you some amount of flexibility and latitude. But the number one reason customers prefer to use a managed service for any database, not MySQL, any database, it's availability. And this is something which we are paying a lot of attention to. We always were, but even more so in the last 1 year. And I would say we're reaching a point where the availability which we get with HeatWave for OLTP workloads with MySQL is probably the best for any other, compared to any other MySQL-based managed service. Now, I talked at the beginning of the presentation how we are taking learnings from the cloud and incorporating them into the on-premise product. And here are some examples, like up-to-date, aware primary election, automatic eviction of resource exhaustion. So I won't get into the details because Louis is going to do a much better job than I will in the next presentation. But the thing which I wanted to point out is these are now capabilities which are available in the Enterprise Edition. Our experience shows these have been very, very useful for the cloud. So if you folks are on some version of MySQL, these features by themselves would be a reason enough to upgrade to the latest version where these capabilities are available. Now, in the realm of availability, some people think of Kubernetes to be features for developers, which is true. But now, again, because of the feedback we are getting from our customers, both on the cloud and for on-premise, people want the enhancements not just in the cloud, but they also want on-premise. So what we now have is operator support for point-in-time recovery and operator support for disaster recovery, right? I'm sure you folks are familiar with this, but the idea is that if you want to have a VM and if you want to simulate a similar environment, then you get with a managed service. These are some ways to do it. And this is something which is going to be rolled out in the next 1 month. And again, I hope that this helps you to take MySQL and offer it as a service, or offer that within your enterprise using these operators. As I said at the beginning of the presentation, we have 2 goals with MySQL. One, to make MySQL the best platform for developers to build new applications. And the second one is to make it the best platform for deploying it. So coming to the developer productivity, that's something which we have always looked at in the context of MySQL, but we are doing a lot more. JavaScript is one of the most popular languages for developers. Right now, customers develop a lot of JavaScript applications with MySQL, except that they fetch the data from MySQL and they do it on the client side. We are providing, it's been over a year, JavaScript runtime inside MySQL, which has a host of implications. One, you no longer need a client-side compute for running this JavaScript. It can be done in the server, right? So you don't need to pay for the client. It is a lot more secure because both the data is inside MySQL and the processing can be done. It saves on the round-trip latency, right? So these are some of the reasons we decided to do this thing. It was available in the cloud. We are offering it in the on-premise edition. But the delta we have in the last, let's say, 6 to 8 months, The first is that many of the times people prefer JavaScript, like other languages like Python, is because it's a very rich ecosystem of libraries. And when people are building applications, they want to leverage those libraries. So now what we have support for in JavaScript, in MySQL, is a support for library. The second thing is, and I was mentioning it for those of you who might have been in my talk yesterday, that one of the merits of HeatWave is that it does a lot of the computation you may want to do with data inside the database itself. And one such example is machine learning, generative AI, transaction processing, and JavaScript. So when you want to build rich applications, you can definitely use OLTP and JavaScript already. But if you want to use generative AI or ML, now you can do all of it inside the database. So in order to facilitate that, we have extended the APIs of JavaScript so that you can invoke the ML APIs, which are in HeatWave, and also the generative AI APIs. So this is cloud only, right? But the point is that now if you have applications which have a combination of which want to leverage JavaScript as well as ML and GenAI, you can do it all inside the database, right? And JavaScript is usually like a preferred language when it comes to string manipulation. And particularly with generative AI, when the input or the output from an LLM is text. So what we are seeing is more and more use cases where people want to use JavaScript with the output of the LLM. Now, one of the teams which has done a really good job, has been Mike Zinner's team, who does work on the client side. And the MySQL Shell is very popular. We provided the VS Code plugin. And one of the priorities for that team has been to enhance this plugin and MySQL Shell for the new capabilities we are adding both in JavaScript as well as HeatWave. So the idea is that if you are developing an application, regardless whether it's open source, enterprise edition, or in the cloud, MySQL Shell and the VS Code plugin will integrate and allow you to develop features for all these three versions. This is a big deal, right? The MySQL REST service, but I just want to be clear that that you're aware of what was happening earlier and what's happening now. So in the past, we had support for the REST API. And by having the REST API, think of this way, that we were already reducing the need for a mid-tier, and we were kind of bloating the client, that on the client side, if there was a REST call, we could make the conversion on the client side with the router and send it to the server. Now what we are doing with the MySQL or HeatWave REST service are two things. One, the router actually runs in the service, right? So when you instantiate the HeatWave service, it gives you an option that you want to create or enable the REST service. If so, we run the router on the same VM where the database is running, completely obviating the need for a mid-tier. That's one. And the second thing is when a client comes in, when a REST request comes in, we are integrating with the various capabilities, like as Sandeep was showing in the demo yesterday, with generative AI, with ML, with JavaScript, so that it becomes very easy for the application to invoke their functionality which is running in the server. This, I believe, is probably one of the biggest things we are doing for developer productivity, because many of the applications are REST clients. And now, not only do they not need a mid-tier, but it is also the case it makes it very, very easy for them to leverage all these capabilities, both for the on-premise edition of MySQL as well as the cloud. And out of the box, and this is something which we are hoping, we will roll out end of next month. And we are providing a lot of APIs already out of the box. So for tables and views, there will be endpoints which are created by default, and we will have more white papers and use cases around this. Now, one of the things, right, anytime, particularly for a database like MySQL, people want to have a lot of clients connecting to a database, because at the end of the day, you want to have one database which is serving many clients. And the bottleneck can be the server, or it can also be one of these, the mid-tier or a service like this. So this is the experiment we ran. What we want to make sure is by adding this router or the REST service, it should not impact the maximum throughput or the maximum number of connections the server can handle, right? So with or without, it should be about the same. So that's one thing we did, and we are pretty much there. But the second thing is we want to compare the performance of the MySQL REST service with the competitive services, right? So the Nginx is pretty much the state of art, and as you can see, shown in the blue line, the MySQL REST service is fairly comparable. And then for the dynamic endpoints, we were comparing the performance. If someone were to develop an application on their own, what would the performance be? So in both the cases, it's pretty good. And then if you just look at the raw performance it's offering, a machine with about 64 cores can handle about, give and take, 100,000 requests. So we feel it's a fairly efficient engine, and it's going to significantly reduce the complexity for the application, reduce the complexity of setting things up, and provide a very good performance. And then, although along the way I was talking about some capabilities for the cloud, but let's talk about what are the capabilities or enhancements we have done in the context of OLTP applications for the cloud. So as I said, our number one priority for the last 1 year, right, since we met last year, and many of you had given this feedback, was to provide better availability, right? And the better availability can be both planned downtime or unplanned downtime. So planned downtime examples would be if you're doing an upgrade. We want to make sure that you get a very minimal downtime, and now it's down to about 2 to 3 seconds from almost 20 to 30 seconds. Similarly, the unplanned downtime. So suppose there's a failure, software failure, hardware failure, and we want to cut over to the secondary, we have significantly reduced the downtime. And if you were to ask me one thing which you have done for the customers, which I think is a very big deal in the last 1 year, for the HeatWave service, it's this. And this has spurred a growth in many workloads which customers earlier would not bring into. Now, I don't want to get into the details of the architecture of HeatWave MySQL with Aurora, but sometimes people say, hey, with Aurora you get a better performance. Here's the thing. Performance means many things, but the number one thing from what I can tell talking to many customers which they want is to minimize the downtime. Sure, there may be a higher replication lag with the group replication we have, but that's something people know, people can predict. But if there's a failure, they want to make sure that the secondary becomes the primary and things move on. HeatWave MySQL provides the lowest downtime compared to any service, including Aurora, right? So, and this is a thing which really matters for customers, and that's what we have done a really, really good job at. The second thing is about the inbound replication. So it's very often the case that customers will have, or they'll be using the service, the HeatWave service, and they may have another database, MySQL database, from where the data is coming. It could be Aurora, it could be on-premise. And this is another area where we recognize the importance. Just because we are seeing more and more customers use HeatWave for OLTP processing, we want to make it easy for them to migrate their existing applications. But if they cannot move the existing applications, it's fine. They can turn on the inbound replication, or they can replicate the data either from some of the service like Aurora or from on-premise. And there we have made quite an improvement in terms of the performance. These are features we have done in HeatWave OLTP for the basic, both standalone and HA. So this is more from a standalone perspective. But there are two things I want to highlight over here. The first one is, again, it revolves around ease of use, right? So we want to make it easier and easier for people to change the configuration without having to file a ticket. And there are other things like, the storage expansion. So this to me, okay, is incremental. But the other thing which I really want to highlight is auto-indexing, right? So here's the thing. If you have an application and you have a performance problem, you're going to figure out there's a problem, and you're going to talk to the DBA, try to figure out which indexes to use and such, fine. But what is interesting is that if you don't have a performance problem during query, you may not even recognize the fact that you can do better than that, right? So typically people tune performance when they have a problem, but if you have a lot of hardware already, you may not have a problem, right? So what auto-indexing is very good at is not only telling you when you need to create more indexes, but what is interesting is when we ran on a sample of our customers' data sets, there were many, many cases where the system made a recommendation that, hey, you know what, you can drop your indexes, and by doing so, your DML performance will improve. So what we now have is, and this is something we're just rolling out in the next couple of weeks, that we're going to analyze, which of the customers' workloads can have a significant improvement by creating more indexes or dropping them based on the queries they are running. And we will send them an email notification as an advisory saying, hey, you know what, this is how we feel. Is that something you want to act upon? But this is something which I feel is going to be very helpful because it advises you on things which you may not know are a pain, but it can optimize you either for even better performance or perhaps reducing the amount of hardware you're running on. And this is cloud only. We talked about enhancements we have done for manageability. That continues to be a very important aspect for anyone who's using a database because they want to get the various telemetry out. And one of the interesting things is with open telemetry that you can even use it with your own tools. So we are providing some tools. We are providing the same quality of managing your database of MySQL as you provide for the Oracle database, right? Which is a very, very high bar. But for whatever reason, if you want to have your own tools, that's fine too. With open telemetry, you can get this information out. And then finally, one of the things I want to point out is whatever capabilities we provide for both, whatever capabilities we provide in OCI for HeatWave, we strive to provide all of those capabilities, identical functionality in AWS, right? And there's always maybe a lag of maybe about a quarter, but we try to even minimize that for new functionality. And for many of these things like HA, where the HeatWave service on OCI had a head start, we are now catching up and we have these capabilities on AWS. And in some cases, actually, because of the difference of say maybe the hardware we're running on and such, we find in some cases actually the performance can be slightly better. But that's more because of maybe some hardware ships being different. And we recently announced that we have 2 new regions where HeatWave in AWS is available in Oregon as well as in Seoul. So with this, I just want to kind of conclude saying, hey, we continue to work on the goal of making MySQL the best platform for customers to develop applications and deploy applications, both on-premise and in the cloud. And by having a single team which is doing both, what you can be assured is that whatever applications you develop in the on-premise will migrate very easily to the cloud. And by having HeatWave be offered in multiple clouds, you have complete flexibility that you can go to different clouds, still use HeatWave, still get the same semantics. And this is not even withstanding all the benefits you can get if you were to turn on the query accelerator, which gives you the industry's best performance for analytics. It gives you built-in generative AI. It gives you the capability to query data which is in files. So with that, I'd like to conclude and happy to take any couple of questions.
Have any questions, please raise your hand. We'll bring a mic for you to get so you're recorded on the video. If there's any questions.
Right. Thank you very much.